Okay, hello everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream on Twitch. No libraries, no engine. It's all our own code, right down to the individual little tiny baby little pixels on the screen. Every single one of those, we put them there by hand, and it's been pretty glorious, I have to tell you. Yesterday we implemented asset streaming in the background. Because I, for some reason, just decided to do it. It was not at all planned. That's just what happened. But we didn't have a chance because we, again, only programmed for an hour on it. We didn't really have a chance to do all of the things that we might want to do with asset streaming, so it's still a little bit primitive at the moment and is not something that you would actually want to call done because it has a number of issues. Mostly, the biggest one just has to do with how it uses memory at the moment. It does not really have any strategy for what would happen if the total number of assets that you were going to use in the game did not actually fit in memory. Now, it's entirely possible that for our game, all of the assets will fit in memory because machines have a lot of memory these days. And so we could, choose to ignore that problem if we wanted to, but I would rather not do that because I would like the game, much like how we've been trying to make all of the programming be very industrial strength here on Handmade Hero, I would like to make sure that our engine could handle the situation where you have vastly more art resources than can fit in the memory of the machine at any given time. So in the case where you have a user who has 4 gigabytes of memory in the machine, it should be able to handle a situation where the uncompressed asset load for the game was 32 megabytes or something, right? That we'd like that to be true. So we're going to go ahead and push forward on that and see if we can't bring our background streaming up to a higher quality level where we can sort of start to do some more of those things that we would want in sort of an industrial strength solution. Okay, before I get started, today is day 133. So if you would like to follow along at home, you can unzip day 132's source code, and that is the source code that I'll be programming with today. So if you pre-ordered the game on handmadehero.org, download the source and then unzip day 132's. That's what I've got, and that is what if you start with that source code, you're exactly where I am right now. All right, so let's take a look at what we've done so far so that we can explain what we're going to need to do and so that we can go do it. So we've got our background loading in there, and so now we can see that when we start the game, when it loads instantly, it also, nothing is there yet, and it just kind of pages into the background, which is exactly what we wanted. And so what are the things that this is not doing yet, and what do we want to start making sure that it does? Well, first of all, you can also see that our guy is like floating and things are in the wrong place. So one thing that we do have to do, which is just pure cleanup, is we have to go back and put in that concept of having the displacement because we took that out of there just as we were finishing up yesterday. So we have to put that back in there. That really doesn't have anything to do with the system, though. That's just a minor thing. So we have to do that, but the more important things really have to do with memory, and you can kind of see what I'm talking about if we just take a look at some circumstances here. Here's the load asset work call, right? The load asset work call, obviously you can tell from the load asset work call that we have this sort of process where we're loading a bitmap. And then at the end, when we've loaded the bitmap, we go ahead and set that pointer here equal to the bitmap that we loaded, and this is the pointer that the rest of the game can pick up and use. Now, the problem with this system, we have two problems really. One is that this debug load bitmap call, the debug load bitmap call doesn't in any way guarantee any kind of a bounded memory footprint, right? Basically what will happen is as we run the game, every time we call debug load bitmap, it will load more memory into the system. And so we'll just keep allocating more and more and more and more memory ad infinitum until we run out of virtual paging in the operating system, and then the game will just flat out stop working, right? It'll just crash or encounter an operating system error where it puts up one of those dialog boxes that like your system is running low on virtual memory, right? So it's really bad to do that. I don't really want to do that. Like I said, it'd be fine if you knew that you only had as many art assets as would fit in RAM and you didn't care, then you don't have to worry about it. But I'd rather do something a little better there. So what we have to do here is understand the concept, kind of like if you've ever seen Arrested Development, you know there's a one in, one out policy in the military, right? And so what I want to talk about here is the concept of one in, one out. Which is basically to say that what I would rather do is I'd rather say how big of a memory footprint do we actually want the art assets to take, right? So let's say we say that it's going to be 2 gigabytes. So that's like what we want our backing store to be for art assets at any given time is 2 gigabytes, okay? And again, this is an arbitrary number. We just would pick it based on what we think the minimum spec of a machine for running Handmade Hero should be. Okay, maybe it'd be much larger than that, maybe it'd be much smaller than that. It just depends on the circumstance, right? So let's say we have that, and we have that chunk of memory allocated out of the transient pool. And then we have, on disk somewhere, we've got, who knows, we don't know how big it actually is on the drive, but, because it might be compressed or something like this. But decompressed, we've got 32 gigabytes of art assets or something. So some giant set here, right? And maybe that's pretty small on disk. Maybe it's only 6 gigabytes on disk or something. But, it decompresses out to something much larger than that or who knows what, right? So who knows what the situation here is. But we know that this is how much we would actually have. So what I would rather do is I'd rather say, well, okay, at any given time we have 2 gigabytes worth of art assets loaded, and when we encounter an asset that we do not have loaded but that we need, what we would like to do is take something from here that was previously being used and that we haven't touched in a while, and I'd like to evict that, right? I'd like to get rid of it so that we no longer are storing that art asset, and then I would like to load in whatever the one is, that we're actually going to use and put that in its place, okay? So that's what I'd rather do. I'd rather have something that works like this. And the reason that I'd rather have something that works like this is because then we know that as long as at startup we get our initial memory footprint that we ask for, we know that we will never run out of memory and crash or anything like this. We'll always be able to operate in the size of memory that we are given. And we know that the art asset loading won't ever do anything stupid, right? So that's what I'd rather do. So that's one thing we want to get to. And the other thing that we have to get to that's actually considerably easier than this is just making sure that nobody tries to load the same art asset twice. Okay. So right now what happens is on a particular frame, if we go in here and we say like, only load once. Right? So what happens currently is on a particular frame, if we come in here and we say, oh, you know what, I need you to load the shadow, right? And then somebody else comes along on the same frame and says load shadow, right? Well, the background task for loading the shadow probably hasn't completed yet, so both of these guys are going to do this, right? The first guy's going to kick off that load thread. The second guy's also going to kick off the load thread, when all we really wanted it to do was kick off a single load thread, and the second guy should not have kicked off a load thread, because it's just the same thread, right? This, it's completely wasted work, and it'll be wasted memory too, because we'd lose that allocation in there, right? It would be a memory leak, essentially. So what we want to do is make sure that we also do that. We talked about that a little bit at the end of the previous stream, so we want to do both those things. This one is harder. This one is definitely the easier of the two things to achieve. It's really just about being a little more careful about how we label things. So that's really it, right? That's what we want to do. So I'm going to take these in order of easiness, which is to say that first I'm going to go ahead and put in the align-x top-down align stuff, get that back in there since we kind of lost it. It was supposed to be in there, and then we sort of lost it when we were quickly getting things working yesterday, so we got to put that back in. Then I'm going to do the only load once, and then we'll start in on the more difficult problem of making sure that we always use a fixed resource footprint. Now, granted, that's actually not that difficult of a problem if all your resources are the same size, but when we don't know what the size of the resources are, we kind of have some decisions to make in terms of how we handle that, right? In terms of how we deal with that. Okay. So, here we go. Here we go indeed. So in order to do this here with the align X in the top down align Y, right? I can essentially just, again, not replacing the bitmap debug load call yet, even though that, might be something that we would want to do eventually. I'm going to go ahead and make it so that we essentially do, a little bit of just a branch here and call the original functions exactly how we had them before. Probably we could clean this up a little bit and make this be a little more smarter in the way it passes through, but that's certainly something we can address a little bit down the line, if that makes sense. So in this particular circumstance, what I want to do is I want to store in that load asset work. I want to store these two things that we have here that we were using before so that I can put them in there. I don't actually remember what types those were. Let me go take a look and see. They were in 32, so that's good. And then I'll just store a bool 32 as well, which is like has alignment or something like this. And then I can put that in here as something to check. So if it has an alignment, it'll use the alignment. If it doesn't have the alignment, it won't use the alignment. And again, that's something that I'd rather clean up, but we can push that down to when we're looking at RSS a little more. It really doesn't have anything to do with this routine whatsoever. So in here, I'll just go ahead and assume that it doesn't have alignment. And then later what we can do is anybody who does have an alignment can set that. So has alignment equals true, right? What are these guys? Top down align Y and align X, right? There we go. So if I want to go ahead and insert these in here, I should be able to do so, and then I could just cut and paste the old values that we had in there into the work order, and now the work order will have the information it needs to accurately reflect the stuff that used to be happening single-threaded, so that we're back to like the feature parity of the thing that we started with, which obviously is what we want. So anyway. There we go, and now our guys are aligned properly, which is good, and everything is fine. So now let's tackle that other problem of making sure that things only load once. Now you can see that we sort of talked about this again a little bit, where we said, oh, because someone asked about it on the end of last stream, and I was like, okay, well, eventually we need to sort of upgrade this to have a notion of what's going on so that we can mark things as being in progress so they won't get queued twice. Right? And the way I was proposing to do that was to actually make, an asset thing here. I'm going to call this an asset slot, and then I'm just going to change this right here, this bitmaps bit, to actually be bitmap slots, essentially. So if we do that, then what I would look for is I basically say, okay, we've got this result here. When we're going to return this result, what I'd actually like to do is say, okay, when it looks at the actual result, it's fine for it to go ahead probably and just get the bitmap right from the pointer. That's probably okay. And we'll make sure we always make that be authoritative in terms of whether you can actually use it or not. But what we would like to do is on the load, right? So when we do load asset, when we're about to kick off the asset, what we would like to do is actually ensure that, well, A, that it needs to be loaded, and B, that it hasn't already been queued. So what I'd like to do is basically do something here where we're going to check like so. We're going to check to see whether or not the asset in question needs to be loaded or whether it's already been queued. So what you can see here, what I'm doing is I'm going to check that state, right? And I'm going to see whether it's unloaded. If it's unloaded, then we'll go ahead and do it. Otherwise, we won't. Now, there is something that we need to be aware of here, that this doesn't want to be written exactly this way, and the reason is because multi-thread contention would make it so that two threads could potentially see this unloaded state at the same time, and we want a fair bit of flexibility with loading assets on separate threads, potentially, depending on how we're going to do it. And so I would just like to say this probably is not what we want to do. What we would like to do is we would like to do, again, one of those locked compare exchange, right? Like so. Maybe I'll call it atomic compare exchange, right? What I'd like to do is atomic compare exchange of an integer here, right? I guess this is technically uint32, right? I'd like to do an atomic compare exchange of that uint32. And what I want to do is say, okay, I want to atomic compare exchange this with that and set it to queued, right? So I basically want to take this guy, I want to make sure that he's unloaded, and assuming that he is unloaded, I want to then set him to queued. And then what I can do is just check the return result to make sure that what I actually got back was unloaded. Because if that's true, that means no other thread could have seen the unloaded because it would have been replaced with queued by the time that they did, right? And so what I want to do is make sure that that state, again, is always going through that atomic compare exchange so that we know that we're not going to have any kind of nasty contention there. Right? So there we go. All right. So that's pretty much it for doing that. What we do have to do, of course, in the intrinsics is we have to actually make these. And unfortunately, again, these are ones that are dependent on the particular compiler in question. So they will be things that people porting to other platforms you're going to have to deal with. You're going to have to specify what they should be, if that makes sense. So in here, what we've got to do is we've got atomic compare exchange uint32. I should probably actually delete this because that way people to do case you need GCC LLVM equivalence. So anyway, we need to do atomic compare exchange. Oh, and we even have complete previous writes before future writes in here. How come I didn't just use that? Because we're supposed to have this fence in here. Oh, good, now we've got that fence. So if we have atomic compare exchange uint32, what that's going to do is it's going to take, a pointer to a uint32. This is the sort of the value to change, right? And then we have the expected value and the new value, right? And what that's going to do is that's actually going to call right into the interlocked compare exchange function, which I don't actually remember exactly what intrinsic it actually is, but here we go, new. And then we have the result, which we need to return. Okay. So let's see what that has. Interlock compare exchange cannot convert argument 1 from volatile to long. That's totally fine because those are the same thing. There's your cast. Let's see here. Okay, and that's it. Oh, well, no. Atomic compare exchange to uint32 cannot convert 1 from asset state to uint32, so we have to do this one as well. So there we go. And this guy here, it just needs to be talking about the bitmap explicitly. And once it does that, of course, it also has to go ahead and set the state to the correct state value, which is loaded, right? So I think that should be good. So that way we get the bitmap pointer in there, we've set it to loaded, so we know what's going on. And then we can retire that thread. So I think that should be fine. I suppose it's also possible for us to do that slightly differently, but I'm going to go ahead and leave it like that for now. All right. Oops, I don't know why I said stamp. So I think that should give us what we want. And now we should have some protection from the case of calling this multiple times. Of course, again, we don't have a whole lot of debugging visualization stuff in here yet, so it's pretty hard for us to actually know that it's working properly, but that is something we'll have to address a little later on when we can maybe visualize a few more things. So that's good, and that's roughly what we have to do to make that lock out. But now we've got sort of some other little bit of nastiness to deal with, right? So if you remember, we do have a problem with our code, which is that fill ground chunk, when we call fill ground chunk, what that actually does is that just builds the push buffer stuff, and then it goes ahead and you know, puts a work order in, right? And you know, there's an issue with this, which is that if the thing that is being composited doesn't exist yet, the bitmap that was going to be used doesn't exist yet, then when this goes to do its rendering, the rendering will be incorrect, right? Because it will be missing one of the stamps it should have stamped in, and we'll just get an incorrect ground chunk. That's might be fine when we're talking about the actual frame buffer, when we're rendering actual frames from the game, because at worst case it's a flicker, but more often it'll never happen because we're streaming far enough out that things will have time to page in before they actually move onto the screen. But we don't have any such guarantees here. And once if we even have one failure in here that gets baked into a ground chunk, you're going to see a lot. That could be a pretty bad error that I don't want to have. So we have a couple different ways that we can approach this, and I'm not sure which one is the best one, but one way to do it is to make sure that all of the stuff that's used in ground chunks is always resident and cannot be evicted, right? That's one way. Another way to do it is to only allow the ground chunk to be filled in the case where it actually got all of the things that it actually needed, right? And the final thing would be to make it so that it just stalls out and waits on loading until the loading is done, right? I don't know if that makes sense. I don't know which of those is best. Certainly the simplest one for right now is just to make sure that it, you know, to basically not mark the ground chunk as actually having been filled until you actually know that everything is fine with it. So the way to do that, for example, would be something like this. I don't know if this makes any sense, but hopefully it will. Let's say I do all this work here, right? I can then say if all bitmaps valid on the render group, then go for it, right? And so what I can do is go into my render group here and say, all right, there's a call called all bitmaps valid. What all bitmaps valid does is it checks to see whether or not you've ever had a cache miss in that case. So all bitmaps valid, render group on the group, right? And if all the bitmaps are valid, then it can render, right? So there's that. There's one additional piece to it, so we'll see. Again, like I said, I don't really know if this is a good way to do it. It might be that we want to just always force ground chunk members to be resident, but you know, again, it's an educational stream. I want to show options and I want to show things I consider doing, so I'm just going to put this in here and see, you know, what happens. Bitmap, or missing bitmap count, right? Or we could even just say missing resource count. So when you allocate a render group, okay, when you come in here, when you start off, it'll just assume that the missing resource count is 0, and then later when it goes, if it has to issue a load asset call, what it will do is it will inc the missing resource count so that everyone knows that there are resources missing. And then at the end, when you say, like, I guess we should say all resources present, might be a better way to say it. All resources present. What we can do there is say, if all the resources are present, it will return true, right? So it's just group missing resource count equals 0, and then you return. So that's one thing we could do, right? All resources present. Now we know that we'll never actually fill a ground chunk. We'll abort if it turns into a circumstance where the stuff that it had wasn't there, right? So we can do that. there's a problem with this still, even if we do it that, which is that technically, so one thing that we can do with the main renderer is we can make it so that during the time when stuff is going to be rendered, we can guarantee that nothing is going to get evicted from the resource cache, right? Because we could just make sure that resource eviction happens at a known time, and that time is not during the rendering. So that would be fine, right? But with ground chunks happen on a separate thread. So what could happen here is we could go ahead and pull all these in, right? Then be about to render them and have one of them get evicted. So the reason that, and that's really bad because actually what that would do is that would potentially even crash because when it goes to use one of those bitmaps, it will find that there's just, could be a garbage pointer or a 0 pointer or it's just it's other memory. It probably wouldn't crash. What it would really do actually is probably just split the wrong sizes and the wrong data completely. It would be bad, right? And it could crash if the sizes got corrupted to be things that were large enough, right? So it's a bad situation. And so the question is, what do we want to do about that? Is there anything in particular that we want to do to try to combat that, right? And there's a couple things we could do. So one is you can just cross your fingers, right? One is a finger crossing. And that would be probably not such a great idea, I think. And the reason you can cross your fingers is that depending on how you implement your least recently used scheme, you can probably be sure that if you just went through and asked for all these bitmaps and they were there, they've all been sort of marked hot and will not be evicted anytime soon, right? It'll be many frames from now that they would ever be evicted, if they're going to be evicted, right? So you could cross your fingers and just hope. Not actually fabulous, but it would probably work, right? You certainly wouldn't crash any more frequently than anyone else's games that get shipped, but it would be nice to be able to do something that was at least going to be theoretically correct. And so the other things we could do is temporarily lock those resources in by every time that we actually use one in the renderer, we do some kind of a state change on that resource to make sure that it changes to a state that is basically a used state. And then when we're done, we clean up the used state, right? And I don't really know what to say about that. I mean, it's the correct way to do it, probably, I would say. It's not hard to implement. The only thing that's a little bit problematic about it is that it does involve reiterating over the buffer. So, I don't know. I don't know what to say about that. But it's an option. So you know what? Maybe I'll just write it, and we'll see how it is. But basically what that boils down to is when you go and do and allocate, when you're in the render group, right, and you do and allocate render group, then what you would need to do at that point afterwards is you would need to go and have a sort of cleanup, right? We would actually need to have cleanup. Which is annoying. I hate cleanup because it's something that someone might forget to do or that might take longer than it should because you can't just go ahead and straight up reuse the memory. You've got to actually do that step of cleaning things up, but who knows. So we'll go ahead and say, here's the group, and then we can say like clean up render group or something like this. And what that would do is that would just step through these guys, right? It would do nothing other than stepping through this list exactly the same way that the other people are doing it. Only this time, what would happen is each time through, any of these guys which actually had something in it that needed to get free, which would basically be the bitmap one. Oops, let me do that. That would basically be the bitmap one here. that one would have to mark its stuff as not being used anymore, right? So yeah, so you'd have something like this. And again, this is one of those things that, looking at this, if we're going to have two people who iterate over it, it feels like we would probably want to pull that out into something that's going to be a little more easily shareable and harder to screw up. The only problem with it is, since it is a rendering thing, I'm a little hesitant to do that. I don't love that idea. But, you know, we'll see how it goes. Again, like I said, most of the time, it's exactly sort of that, you know, it's that we'll see how it goes kind of a thing. So yeah, so in here, if we do the cleanup render group call, what we would need to do is, assuming that it was actually a bitmap that we were using, we would need to be able to release it, right? So we need to basically like release resource. And in here, the loaded bitmap, or not, sorry, the loaded bitmap, the actual thing that does it would have its game asset ID in here, right? Like so. Yeah, we wouldn't probably need the loaded bitmap pointer anymore, for that matter. We would just record the asset ID, and that would be it, right? So it would probably be something more like this, where the bitmap actually comes in here. Although I don't know, it may be that we need that bitmap pointer a little earlier on to get like the dimensions of it. Let's take a look, because I don't actually know. I don't remember. So let's take a look at what happens there. Yeah, so as you can see, we actually use that bitmap information. So it means we do need to have the pointer a little earlier on. So we do need to actually still store it, if that makes sense. So what I'm going to do here is just say, okay, you know, if the entry bitmap actually was valid, then I've got that game asset ID. I'm going to have to release asset or something like that. Release asset, something like this, or unlock asset. And that would just be whatever the entry ID is, and this is the group, the assets, you know, for the group, right? This game asset ID, where is that actually? There it is. Okay. So where am I? Yeah, so this actually wants to be up there. There we go. And this is render group, right? So this is going to unlock that asset, and then what we need to do down here, right, is when we actually do the push bitmap call, we need to lock the asset, right? So we need to do a lock asset call, like so, and assuming that that succeeded, then we should be able to, you know, dispense with this check. Yeah. And in fact, I guess we can dispense with the check up above as well, because since we have to get the bitmap in, we don't actually need to do an if bitmap anymore, because that's just never a thing, right? We always know that we had one, because otherwise we wouldn't have pushed the call. So yeah, so that should be exactly that. So yeah, so that would really be all we would do. We have the lock asset and the unlock asset, if that makes sense. You know, again, this is why I say it's kind of ugly, and I don't super love this. I would probably say that based on how much I'm seeing here, I would say that the better thing to do is just leave ground chunk bitmaps resident at all times, so they cannot be evicted. It's like unevictable, if that makes sense, because the number of things that are going to be participating in them is probably so small. They can still be streamed in, they just can't ever be streamed out, right? But we'll see. We'll see. So the way that that would work is in here we've got, you know, our asset state, right? And in there we basically need a lock count, which would tell us, you know, how often, you know, how many people were using this thing. Now, if we wanted to, we could also say, oh, you know, actually this lock count could just be one thing. We could just have a single variable, and you know, you just kind of like increment on it or something like that. And yeah, I'm not sure I really like that. So yeah, it would be something like this, where you just do a lock count, and then inside lock asset, it would be a locked increment, and outside it would be a locked decrement. You know what? Having seen all that, I'm just like, I cannot believe that would ever be worth the trade-off. It just doesn't seem like it would ever be worth the trade-off to me. I can't see that being a good idea to me. It just seems like it would be inviting trouble in so many places, right? So I think what I would rather do is just say that those assets get locked. That's just how they work. They're just always in place, right? So I think that's what I would do. I think that's what I would prefer. So I'm going to go ahead and back that out. I just really don't like that. That was giving me a really bad. It required so much more stuff for such a small. For really just such a small piece of the code, because everybody else doesn't need that feature, and so like putting it in there just for background loading of ground chunks just seems so bad, right? So that's my call on that. I'm saying it's not going in. That is not happening. Okay. So that's out. That is out. Oops. I went too far. My bad. Sorry. That's still fine. There we go. Okay. So let's see. All right. Just making sure everything's kosher there. So yeah, so I don't think that's a good idea. I don't like that at all. So what I would rather do is say that there's a concept of a locked resource, and locked resources are not allowed to get streamed out, if that makes sense. So I'd much rather say something like asset state locked, and a locked resource can never get streamed out ever. Once it's loaded for good, right? And the way that I would do that is inside load asset. When we do this stuff here, at the end of this work, when it gets set so that it says that the asset state is loaded, what I'd rather do is say final state, like so. And that way, we can have the luxury of marking anything we want to be locked. And then that thing can never be streamed out ever again. So that seems better to me. Right, there we go, asset state, final state. And so in this case, right, we don't have any of these can all be streamed out. They're not a problem. But when we add things later that have to be in the ground chunk arena, I shouldn't use the word arena, but in the ground chunk usage case, then those have to be locked, because anything that happens for the rendering on the other thread has to stay locked. And we'll see how that goes. If we decide that it's too much or too onerous for us to do that, like there's too much stuff that has to stay in memory in that case, we can always backpedal on that. But that seems like a pretty reasonable compromise, because it means that there's just a hell of a lot less code to deal with. All right. So there we go. That is basically it for all that stuff. We still have to do some of the structural things, but at this point, I think we should probably start to talk about eviction, right? Since it's a thing, we should talk about this stuff, the one in, one out stuff. So what we want to do here is when we load an asset, currently what we're doing is, I think, the debug load bitmap nonsense. What's actually happening here is it just reads the entire file and then it pretty much, I think it just does its work in place. Is that correct? Yeah. Yeah, source dest. So you can kind of see here, right? When we load these bitmaps in, the bitmaps are just getting loaded. They're getting allocated by the platform layer, and we just always use that memory in place, right? So really, we don't even have the option here of doing anything smart about this when we actually load this guy into memory. So I guess maybe it's premature, now that I think about it, to do this quite yet. It may be that what we would rather do is actually tackle this other part first, which is like the bitmap structural stuff. Because what I'm seeing when I look at this, and I suppose I could move this back down to where we had it before now, like so. What I'm seeing when I look at this is it's looking to me like we'll want to start working with a table of what are all the things are that we have in the game. And if we're working in that space, I feel like that's where we want to start to do stuff like have a general table that stores all of our bitmap information and this sort of stuff. So I kind of feel like that's where we should actually be headed. So I think I'm going to push that direction first, finish up that part of the asset stuff, which isn't really have anything to do with background streaming. That's just starting to put ourselves in a more complete position in terms of just our asset concept in general. I think I'd rather do that and then come back to the sort of memory management aspect of it. And again, we're under really no pressure to do that because we don't have hardly that many asset resources. I don't even know if in the end we'll have that many asset resources. I suspect we will, though. Like, our uncompressed asset load could very easily be well above, say, 4 gigabytes or something that might be a reasonable footprint for a game on, like, the lower spec machines or something. Although, yeah, I don't know if that's actually true, because on the lower spec machines, you probably wouldn't be loading the highest res art, so you could do other stuff, but yeah. Suffice to say, it could happen. So anyway, what I want to do here is start to tackle some of these other problems. So we have these arrayed assets here, and I'd like to start to tackle the arrayed assets as something that we want to deal with, right? And so we have a game asset ID here. What I'd like to do is expand the notion of a game asset ID to talk about things that maybe don't really have anything to do with specific bitmaps and that are rather a more general concept of what is going on, right? So we've got two types of things there that we would expect. We have grass, stone, tuft stuff, which is like an array of things. So we have like grass and there's some array of them. And then we also have things like hero bitmaps, where the hero bitmaps have like a facing direction, and then there's like some of them, they're like kind of paired together. So we kind of have two sets of things that we're talking about, two types of structure that we want to address directly, right? So what I'd like to do with this one here is I say, well, okay, we've got these grass arrays. What I'd like to do is introduce sort of the concept that we have, you know, I don't know what you want to call it, a game asset, I don't know, maybe a game, let's say asset bitmap label or something like this, or something. I'm not sure what exactly it would be called. But what I want to do is basically something that describes this particular thing, right? And so loaded bitmap, you know, is basically what that was before. All we would use is in the render group, we'd have loaded bitmap, and you can see exactly what it has on there. It's got a line percentage, width over height, width, height, pitch, and memory, right? It's got that stuff. What I'm more interested in now is the part of these things that we might want to save as a descriptor of this thing, right? We don't care about the pitch or the memory. That's like stuff that's loaded. I guess we could call it bitmap info. And these are some properties that we know we had. But in addition to that, maybe we also have like a couple properties or tags of this thing that can be on there, right? So maybe we have something like an asset tag, right? And that asset tag is like the tag and the value or something like this, right? And there's something in here of the form, you know, tag count or something like, you know, first tag index and tag count, something like that. I don't know. You get the idea, right? So what I'd like to do is sort of talk about, like, can we make something that allows us to start to create a table of these assets where the code could read the table and know something about what it was getting, right? And so, for example, in the case of like the grasses or the stones, right? Is there some way that we could make a way of marking up the art assets to say that here are the things that ground chunk construction are concerned with, and here are some that represent like a stony surface, and here are some that represent a grassy surface, and for the ones that represent a grassy surface, here is like this and that and whatever, right? So I'm just wondering if we can maybe do something like this. I don't know if that's a good particular way that I've got it in there right now, but that's sort of the thing that I am going to sort of look towards. So what I want to do here is write the usage code first. I want to write the usage code so that we can see how it would actually play out in practice. And so I'm going to go over to fill ground chunk, right? And in fill ground chunk, you can see that it sort of does this random seed stuff here, right? It's doing a random seed thing. It's a little hard without having more world building code to know exactly how this would work, but you can kind of see in here when it picks stuff. Wait, sorry, that random seed is for initializing the series. Sorry, I was back a bullet. It's random choice, right? It's randomly choosing between these things. It randomly chooses between one of two different things, and then it randomly chooses in here out of whether it's going to put down stone or grass or whatever, right? This sort of stuff. And in the decoration case, does basically the same thing. It picks one of the random tufts that it has there or whatever. So if we think about what that's doing, you could imagine if we were trying to fill a ground chunk where we had specific information about what was supposed to go in this ground chunk, you could imagine, first of all, us wanting to make this choice not necessarily randomly. Like, for example, we would say whether it was grass or stone would be based on some input as to the region that we were placed at, the current like location, right? And the other thing that we would want to do is in here, where we're doing things like random choices, we may want to pick choices that make more sense for the area. So for example, if this is an area with taller grasses, then maybe we're erring on the side of tall grasses more often than other grasses, whereas if we are in an area of short grass, then we wouldn't pick the tall grasses, right? So that's just what I'm thinking. I'm trying to think whether I can really emulate that with the art assets that we have in here right now. Oh, I can. You know what? I could just scale them and pretend that. But let's take a look, because I don't actually remember. It's been a long time since we actually took a look at any of these, what they actually are in the tuft case. So there's the tufts. I don't really have much in here. I probably should have put in some more art assets sometime soon, so we can start playing with them. The rocks, however, I guess are a good example. You can see there's like a flat rock as well as some more bulbous rocks, and that would be an example. But yeah, I don't know that we really have anything we can super test with. So maybe I'll have to go dig around and put some more art assets in there that we could use for this. But suffice to say, the way that we would do this, presumably, is it would basically rank the ones that are in there. I don't know if it would be a little too long to rank each individual one, but yeah, that's sort of what I'm thinking, right? That's sort of what I'm thinking. So how to do this efficiently? So here's one way, right? Let's say you have these tags, right? Let's say I have something like asset or int pick best, right? And I was going to go over some array of these asset bitmap infos, right? So I had something like this, and I was going to iterate over these. So I have an info count, and I go over them, and I do this, and I oops, that's not what I do at all. Sorry, I do this. And inside here, I'm just going to loop over however many there actually are, right? And when I do this, what I have to do now is rank the tags of this guy, right? So I would essentially go, tag index equals first tag index, and then I would do tag index is less than, in fact, this is probably one past last tag index. So I would do something like that. Tag index, like so. So I would go in through this table, and I would read out what all the things were in there, right? And when I did that, I would be able to grab whatever the tag was. So I'd have an asset tag, and I would see which one it actually was, okay? And I'd probably also have a thing in here that was like match vector, right? And so what I would do is I'd say, all right, the tags list, right? Whichever tag index this is, I'd go ahead and take, the difference or something. I could also do the weight, something like this, match vector and a weight vector. What I do is I'd say, all right, the difference here is whatever the weight vector is for this tag, ID or whatever, right? For this tag ID times whatever the match vector is for this tag ID, right? The absolute value, of that and whatever the value of the actual tag is, right? Like so. I should probably maybe do it like this so you can see it a little more clearly. So I have the difference, which is just the difference between the tag value and what I would want to get. And then I would have something that sort of does a weighted difference, right? Weighted, like so. And then I would sum those or something. So I'd say total diff, or total weighted diff, equals 0. Total weighted diff plus equals weighted. And then I would say, okay, whichever one was best. This would be the best diff here. Best diff would be real 32 maximum. I'd come through here and say, if the best diff is greater than the total weighted diff, then the best diff equals the total weighted diff. And I'd also have the best index here. And I'd say best index equals info index. So this is the super slow way, right? So basically what could happen is here's someone who had a particular idea of something that they wanted to grab, right? And all of these bitmap infos would be marked up by tags that were basically some set of IDs, just I don't care how many there are, and I don't care what they mean, but we just agree that any particular piece of code is using some set of IDs that the art assets have to be marked up by, and those IDs have some value associated with them. These could be stuff like tallness, and then this value would be like how tall the thing is, right, or whatever. This thing that does pick best would then actually just do that. It would go through these things, and you'd pass in a match vector and a weight vector. The weight vector is how much you care about, from 0 to 1, how much you care about each of these traits, and this is what the value of each of the traits is that you're trying to match. You would then go through, and for each one of them, you would see how far away you are from the desired value and multiply that by whatever the weight was for that. And then you'd see who came up with the best score. That would basically allow you to select out of a pool of assets that you'd never seen before and had no idea what they were. It would allow you to select the one that best matches the criteria that you're trying to get for whatever the thing is that you're trying to draw, right? And so, you know, that's one example of how we could do it, right? And so when we load in the asset pack, what the asset pack would have in it is it would have these bitmaps. They would be tagged. We would then have at load time all of those tags loaded in, so we would know what bitmap we were looking for at any given time by looking at how the tags matched out for whatever it is that we're trying to do at that time, right? So we could do that, right? We could straight up do that, and what can I say? I can't think of a whole lot of reasons not to do it that way. Seems pretty flexible. And then what we could have on top of that is just some set of fixed arenas so that this search doesn't take too long. Where we would essentially say that, you know, each one of these bitmap infos has something in it, or probably even that they come in bulk groups, right? So we have like an asset bitmap group or something like this, or just an asset group, and that asset group itself has an ID that's like, what are these? Oh, this is hero bitmaps or something like this, right? And so maybe they can be matched kind of like a little bit more hierarchically. You know, or we could even do it this way, right? Where an asset group has a set of tags on it, and so you can sort of pull out particular asset groups that go with certain things that you're trying to do, and then you don't have to search all the bitmaps in between them, right? Something like this. So yeah, I think I'm going to leave it there for now. Because I think, at least at the moment, and I'm going to put this, I'm going to make this compile, I think we want to explore this a little bit more before committing to anything, since we're kind of getting to the end of the stream here. I just want to leave it at that, and we can talk about it some more tomorrow. For now, we can go to the Q&A, because it is Q&A time, as you know. So if anyone has any questions, please go ahead and ask them now. Put Q: in front of them so that I can see them, and please try to keep them to the stuff that we are working on so that it can be on topic. Robot Chocolate Dino. In Pick Best, would you want other types of fall-offs when computing the difference? Probably you wouldn't care. But you could certainly add that, right? When compiling for 64 bits, shouldn't you be using interlocked compare exchange 64? I'm not sure. Are you saying that for like a performance reason or something? The value that we're exchanging is only 32 bits, so I don't know why. I'm not sure why we would do an interlock compare exchange 64 in this particular case. In your example of having 32 gigabytes of assets uncompressed and 2 gigabytes of space for them, are there techniques you can use to tell whether you will need more than 2 gigabytes at one time? Well, obviously you can do this by playing the game and monitoring it. And you can also make reasonably conservative estimates. Like for our game, for example, we know that we're a 2D game. We know there's only so much overdraw and so many different graphics that we're going to have. We can probably put a pretty conservative bound on it. But no, there is no way, I mean, without having some kind of a crazy sort of like static code analyzing solver nightmare thing to actually be able to prove exactly what the maximum you would, the minimum you would need to guarantee that you can always load everything you might need for any given frame the game could possibly draw. But usually you can make sure that you're so far above what that could possibly be anyway that it's not that big of a deal. Can you summarize what you've done from the artist's perspective? Did you add a light obligation to the contract between the programmer and the artist? I'm sorry, I'm not sure I understand that question. Yangshin is a contractor. She's not an employee, if that's what you mean. But, I mean, she's under no obligation to keep working on the game. If she wants to stop working on it, she can, just like an employee could quit at any time. I don't think it's common for contracts to have obligations that somebody, like an artist, stay on till the end of a project. I think that's very rare. Sometimes there are payment contingencies, like, you know, maybe you get some bonus if you stay to completion, or if there's like royalties involved, you only get the royalties if you stay to completion. There's things like that sometimes, but that's the only thing I think of. So I'm sorry, I'm not sure I really understand what the question is trying to ask. If you can't evict locked resources, what would be the point of streaming them over just loading them up front? And doesn't it put a restraint on the diversity of the environments you can have? So I don't think it really puts a restraint on the diversity of the environments you have, because we're only talking about ground chunks. So the number of things that will make up a ground texture, I mean, even if you had to lock half a gigabyte's worth of bitmaps or something, the streaming would still work fine, right? And that's so much ground texture to work with. Like, I can't imagine that ever being a problem. And chances are we're talking more like 256 K or something like this of ground. Well, probably not that. We're probably talking about something like 64 megabytes of locked worst, right? So I'm not sure I care about it too much. Like I said, it looked like the code overhead was just going to be annoying, so I don't think it would be a good idea to do it that way. But we'll revisit that if it turns out we somehow have 10 gigabytes of ground texture, then, you know, we'd revisit that. But I suspect that it will be a very, very small portion of the footprint. As to why you still stream them, the reason is so you never have a loading screen. Like, I always like games to run immediately, right? And so I don't want to have a loading screen that's like, hey, why don't you sit here and wait while I load up all of the ground chunk data, even though we're not going to draw half of it, or even 10% of it for a long time till you get to like the ice area or whatever. We don't need the ice bitmaps, right? So I don't like to waste the user's time waiting for things that aren't necessary. So that's why I want everything to be streamed, even if some things never stream out, because it makes it easier to make sure the code will be correct. Shouldn't you fill work completely before calling platform add entry for load asset work? Yes, I should. Did I miss something? So load asset work, we have assets, file name, ID. I should probably put these in the right order, not that it matters, but task, bitmap, has alignment, align X, top down, align Y file. Yeah, so they are all filled. Oh, no, how did this get there? Thank you for catching that. That was definitely not supposed to be. I did not think that was what was happening. That is totally wrong. Totally wrong. That's supposed to be down here. Yeah, sorry about that. Thank you for catching that. I have no idea why that was there. I must have like cut and pasted something and totally flubbed it. Yeah, but no, that was not supposed to be the case. So yes, you absolutely should. I may have missed this, but do you have the ability to set a hard limit on memory usage yet, so you know you can support lower memory machines? So right now, when we start up, we only do the one allocation, and that's it. So we already only run in whatever memory we have. But that's not really very meaningful because we just don't have any art assets yet. So obviously we're never going to hit that because art assets is what will take up all of that memory. So really the point where we'll be able to say we can set a hard memory usage limit is when we actually go and finish the streaming stuff to have eviction. In a prior episode, you implemented bilinear filtering. Are you going to take it a step further and implement mip mapping and trilinear filtering? So trilinear filtering is never necessary, obviously, because we're 2D flat projected. So there really isn't any. You would never trilinear that, right? You're just literally, unless I'm not thinking about it properly, you never actually need trilinear filtering because you just make sure that your mip maps would always be bilinear downed versions of the higher res stuff, so that you never have to do trilinear, right? But the reason I say, are we going to take a step further? I would say no, we're not going to take a step further because it's unlikely that we're really going to be scaling things by that much more than 2x in either direction. So I don't feel like mip mapping would really benefit us in any particular way. I feel like it would just waste memory. But to be clear, we don't have to do any work to implement it. Mip mapping would be free on our architecture currently. All we'd have to do is switch which bitmap we were using based on the size. That's it. So we would not have to rewrite the renderer at all. We already effectively support mip mapping in that sense. So yeah. So the answer is no, we would not modify the renderer in any way. If for some reason we find that mip mapping is going to be important, meaning we see that we are doing a lot of that scaling and things are not looking good to us, then what we would do is we would just have at the head end, when you do a push bitmap call, it would look at how big you were trying to draw it and pick the bitmap, scaled versions of the bitmap based on that. That'd be the only change. And then we'd have the full quality that you would get if you turned on mip mapping and trilinear in a hardware renderer. Will the assets loaded in from a file be stored and evicted in the same way as the ground chunks? I don't know, because our ground chunk scheme is kind of hacked right now. The eviction scheme was just something we threw in there. So I suppose we'll probably think a little bit harder about it. But I don't know. Questions. Questions. Are there questions on the stream? Maybe there are, but maybe the lag is keeping them from being asked. But there may not be any more questions. Everyone might be totally on it. Benzi, why only BMP? So the answer is we will not. The answer should not even be why only BMP. I'm sorry, the question shouldn't be why only BMP. The question should be why anything. And the answer is because it's temporary. We will not be loading any type of art in the game later, any type of standard file. We'll be loading from a pack file that's our own devising. So that's why we only load BMP at the moment. It just happens to be an easy format to load. And so when I was implementing it to show people how to get that working, I just picked BMP and did it because it's really easy to load. Yeah, in the future, there will be no such thing as loading a BMP. Basically, there will just be a giant pack file. The pack file will have a bitmap format that we have devised, that we are comfortable with, and that we load directly. It will probably be compressed with something like, an LZMA or something, who knows. And we will just have that will be our format in the pack file. So there won't even be BMP loading in the actual version once we finish shipping it. Soy Sauce the Kid. The eviction stuff you're doing, is it basically garbage collection? No, so it's not garbage collection. It's sort of more like, how should I put this? So the way that garbage collection works is garbage collection waits to see if something isn't used anymore. And when it isn't used anymore, it gets rid of it, right? But what this is not that. All of these things are things that we're using, right? Meaning all the assets in the game are things that we're using. But we just can't fit them all in memory. Like, we'd love to have all 32 gigabytes of assets or whatever just in memory, and then we don't have to care about any of this. But the truth is we don't have that much space. So what we do is we page in whatever is being most recently used. So this is not akin to garbage collection, it's akin to virtual memory, if that makes sense, right? We're sort of implementing our own virtual memory. So what we do is we have 32 gigabytes of virtual bitmap space, and then 2 gigabytes of physical bitmap space, and we're just moving in whatever the 2 gigabytes, we're trying to keep that 2 gigabytes of physical mapped to whatever the most useful ones are at the time, right? So hopefully that makes sense. So it really has nothing to do with garbage collection. Garbage collection is about seeing what's used and what's not used. This is not that. This is about trying to keep in a fixed amount of space the things that are most likely to be used soon, if that makes sense. Will we be using AMD hair physics? Obviously, how could you even ship a game that doesn't have AMD hair physics in it? That's ridiculous. Probably what we'll do, and obviously this is hush-hush, so don't tell anyone about this. Like, this stays just between me and the, couple hundred people or whoever who are watching. The entire game will be constructed entirely out of hair. So basically, like, the main character will be all hair. That one that's in there now is just a stand-in. It's just going to be like a hairball. And then, like, all the ground is going to be hair that's kind of, like, matted out. And then the trees will be hair, and the monsters will be hair, but, like, a different color. So, for example, like, maybe the main character will have dark hair, and it'll be fighting against, like, blonde-haired things, right? It's kind of like a statement on racism, if that makes sense. I don't want to go too deep here, but I don't want to bring Ferguson into it, right? But like that's basically what we're going for. So that's why we need the AMD hair physics, and that's why that'll be going in soon. It'll be all about AMD hair physics, and like I said, that's not cosmetic. That's like about theme, and so the AMD hair physics will be letting us address racism in a much deeper way than we could have if like the game was made out of real stuff instead of hair. If you turn a bitmap black and white by altering the pixel, then would you have 2 copies of the bitmap? Would you delete one if you have to? Yeah. I mean, I'm not sure I totally understand the question, but I guess what I would say is the idea is a bitmap is sort of a cache in some ways, right? Like, you could imagine saying, well, what we'll do is we'll procedurally generate all the graphics with some complicated routine that like takes Yangshin's brain and bakes it down into a neural network and then tells it to paint the hero and it paints the hero or whatever, like, right? But what a bitmap is it's sort of like a memento. It's like, here was a process that was expensive to do. It took human effort even, right? To produce what this thing should look like. And then so what we're going to do is we're just going to load that and blip that, right? You can think about that as being true for like all bitmaps. Essentially, any bitmap is just a cache of some process that was potentially expensive. And so what you have to think about in terms of your game is anytime there's bitmaps that I could be generating. So like in your case, you're saying there's a procedural modification to the bitmap, like I'm turning some of the pixels to a different color, right? If there are procedural modifications you can make, you have to ask the same question. Are those procedural modifications fast enough so that they could happen during the frame when we render? If so, then it's probably more efficient to do it that way. But if they're expensive, then it's probably more efficient to cache them in bitmaps and make new bitmaps. And that's like what we did with the ground chunks, for example, right? To give a totally concrete example, in fact, look at the way we deal with the hero versus how we deal with the ground chunks. Because the ground chunks are going to have a lot more logic to them and a lot more splatting. I chose to cache them. The hero is just 3 sprites on top of each other that'll just kind of bounce. So I chose to recomposite them every frame. And that's just a decision that you have to be comfortable with making. Sometimes you have to make it with a profile and actually timing it if you're uncomfortable knowing which one is going to be correct. But it's always about that. It's about what can I do dynamically versus what do I have to cache, right? Why do people care so much about garbage collection? I have no idea. As far as I'm concerned, it's a completely useless concept. Why use a pack file instead of BMPs? What makes it better? So basically, there's 2 reasons. Well, 3 reasons, really. One of them is silly. The silly reason is that I hate games spamming my hard drive with 8,000 files. I just want an executable and a data file. Like, that's it. It's nice and clean. I can copy it around. It's not a nightmare. It's all good, right? So there's a little persnickety there, but that's the silly reason. The good reasons are, one, you don't pollute the OS handle pool, and you're not opening files all the time, right? With a pack file, you just open one file handle to the OS. It knows you're always going to be looking at that file, right? The file is now locked, so no one's going to delete it out from under you or do anything else ridiculous. The OS is expecting you to have it in there. It's warm in the cache. Everything's good. And so it's going to be able to pull those in as full pages and all these other good things. And then all I'm doing is pulling parts out of it, right? It also allows me to issue background reads really easily. There's all these sorts of things. You'll see a little when we get to Packfile how much better it is than individual files. It's way better. But that's the majority of it, right? And the other part that's great about it is also the indexing. So the manifest of all the stuff that's in there, and I don't mean like a Windows manifest, I mean like whatever our table is that tells us about what's in there, can all use offsets into the file, which is just a simple, probably 32-bit number. And that way we don't have to use strings and have strings in there that tell you like what file to go load and all that garbage. So pack files are like, it's not even like a subtly better thing. Pack files in practice are like so much better than individual files that it's like, it's not even a contest. Earlier, someone asked why we implement virtual memory on top of the OS's virtual memory. Are we doing this just so we can have more virtual space? The reason is because relying on the OS's virtual memory is extremely tenuous. You have no idea what it's going to do. You have no idea when it's going to page in. You have no idea which thread is going to hit the paging. It's just very dicey. And so typically you do not want to rely on the OS's virtual memory for something as critical as asset streaming. It just tends to be a pretty bad idea, right? Furthermore, you don't even know if the operating system has that much virtual memory. It's entirely possible that that machine is not configured to have 32 gigabytes of virtual memory. And in that case, you will just fail. So those are not really good options. Yeah, it's not fabulous. You could try using a memory map file instead, which would solve that problem. But then you have the problem of the fact that that's actually not the thing that you're caching. That's probably compressed. So you would need a second memory map file, which was your swaps. Yeah, it's just, there's a lot more complexity there. It's not as simple as just saying, let the OS do the virtual memory for you. It's really not that simple because the paging process involves decompression and all these other sorts of things that are, that the OS doesn't do. Are the ground chunks going to be precomposited when using the GPU? I would assume so, yeah. I don't see any reason why not to, and it'll be much faster that way than trying to have the CPU do them and then upload them, when we could just have the GPU do them directly. Is there a reason why you split the character to 3-bit? Yes, so it can have some nice bounce to it, some squash and stretch. Is the rendering going to be eventually done on the GPU? Yeah, I mean, at this point, it's unclear whether we'll ever really need it, but we would want to ship it that way because, in fact, I was talking to Danielle Bembergui about this just earlier today. It's more power efficient to use a GPU in most contexts. So like on laptops, for example, even if our software renderer turns out to be so good that we could totally ship with it and it's not an issue, it will be much more power hungry than using a GPU for the same workload, I would suspect. And so, for example, on a laptop that was using Intel integrated graphics, I can pretty much guarantee that if we go through the GPU, it will not burn the battery nearly as fast as if we spun up the whole CPU to do that rendering, if that makes sense. But that's just my assumption. Are game saves going to be part of that asset pack file or their own pack file? No, the game saves cannot be part of the pack file. The reason they can't be part of the pack file, among other things, is because they are writable. So the pack file will be read-only and potentially installed on the user's machine in a place that cannot be written to. We don't know whether it can or not. And so the game saves have to go in like a Windows directory that's allowed to have writing privileges and all these other sorts of things. So we want to make sure that we write save files to a totally different location, or at least can, because there's a bunch of compliance reasons why that will have to be true. So in general, you want the save files to be separate anyway, so people could like copy them around or do anything they want, right? So generally, you want the save files to be separate for other reasons too, probably. But even if you wanted them to be part of the pack file, I would probably advise against it because of platform compliance reasons on Windows and on elsewhere. And also for cloud save, right? If you have a save game and you're using, like, let's say we ship the game on Steam and we want the saves to be cloud enabled, that's a perfect example of where you couldn't be part of the pack file because the whole pack file is not going to be resynced every time. So we need it to be like a sort of separate file that's just for save game data. All right, have we come to the end of the Q's and the A's? Q's and A's. Q's and A's. Q's, Q's, and A's. Does porting the rendering to be done on the GPU mean you have to write a renderer completely separate to the CPU one, or is most of the groundwork done by having the CPU renderer done? It's usually completely separate because everything that the GPU renderer does is, all of the things that our CPU renderer does, the GPU renderer has like different calls and stuff for it, right? So probably like the render group.cpp file would be like, replaced by a separate one for the GPU. And GPU rendering is pretty complicated, actually, especially if we do Vulkan. There's a lot of setup and a lot of management, fencing, and all these other sorts of things, right? So if we're doing like a Mantle, Vulkan, D3, D12 kind of a thing, those are, much more low level, and they involve a lot of work that has nothing to do with what the CPU renderer is doing. It's totally separate. It's about setting up things for hardware, right? And so if we end up going that route, which, I think we probably will, because by the time we get to that, either D3, D12 or Vulkan will be a viable thing, I'm quite sure, for us to use, I suspect. Because since the software render turned out to be so good, we aren't in any rush. We can choose to wait till the very end of the project to put in the GPU renderer. So, if we're talking a year from now or a year and a half from now when the project is getting into ship mode or whatever, I feel like we'll be able to use one of those, and there's a lot of work in there. I thought you hated both DRM and cloud-based stuff, based off of Jeff and Casey's show. Yeah, I do. Well, I wouldn't say that I hate all cloud-based stuff. Obviously, I like the idea of backing things up to a server or things like this. I use source code control and stuff like that. I hate DRM, which is why Handmade Hero hasn't any DRM. But I also don't have a problem with putting Handmade Hero on something like Steam that might have DRM on it, as long as people have the choice of buying it somewhere where it doesn't have DRM, right? Because if people want to use Steam and they don't care about digital rights management, then I want people to be able to get. And in fact, the reason I don't like DRM is specifically because I want people to be able to get things the way that they want them, right? And DRM is about preventing you from being able to get the game the way you want and store it the way you want and run it the way that you want. And so I certainly wouldn't prohibit people from getting the game on a platform that they liked, such as Steam, just because it happens to be DRM'd. And also, I'm pretty sure, and I could be wrong about this, that Steam doesn't require the DRM. So when I put it on Steam, I could also, I believe, turn off any sorts of DRM features on Steam so that when it downloaded the game to you, you could then copy those files to a different machine of yours and run the game, and that would be fine. So yeah, just to be clear on that. All right. I think Creepy Uncle Casey's going to go get some ramen now. So let's go ahead and wind things down since I don't see any more questions. Let's go ahead and close this. Close it down. Close it down. All right. Oops. Trying to close it down. All right. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the source code at home, you can always pre-order the game on handmadehero.org, and it comes with all the source code. The handy-dandy pre-order button allows you to get a link in the email, and then you can download the source code any time. After I finish every night, I upload the changes, so you're always current. If you want to just support the video series, we do have a Patreon page, which we very much appreciate subscriptions to. We also have a forum site where you can ask questions, and you can also take a look at community ports there. People have done some work porting to Mac and Linux if you want to try that and you need some help. We also have an annotated episode guide, which you can look at there, which helps to catch up on old things, old episodes you may have missed. And finally, if you're trying to catch the show live, we do have a tweet bot. The tweet bot will tweet the schedule at you. So if you want to know when a stream's going to be live for any given day, that's the place to check, and it should always be able to tell you. That's about it, I think, for today. Thank you, everyone, for joining me, and I will see you back here tomorrow when we will go ahead and push forwards on our asset storage format, which probably means we'll also do some pack file stuff. I feel like now that we're in there, we might as well just finish up asset stuff. Like I said, it's not super complicated, so we might as well just try to get that finished up in a reasonable state so we can just check that off our list and be done with it. So thank you very much for joining me. I hope to see you here tomorrow, 5 p.m. Pacific Daylight Time. Until then, happy coding, everyone.